Okay, in the last couple of lessons that we've had, first of all, we learned what a term was in a mathematical expression. And then in 5b, we learned about the three different parts of a variable term. Now, the next step in the progression here is to learn what it means to have like terms. Okay? Two or more terms are considered to be like if they have the same variable raised to the same power. So I've put a little table here for you. Here's an example of like terms. What you have is the term 4 times x, and then the other term is 5 times x. And because in both of those terms x is raised to the first power, those are considered to be like. If you look at the unlike terms in that row, I gave you 3 times x and 3 times y, and we have different variables there, so that those are considered unlike. Another example of like terms would be 3a to the second power and 6a to the second power. They have to be raised to the same power to be considered like. So on the other one on that row, the unlike terms would be 4 times a to the second power and 3 times a to the third power. And because we have different powers, even though the variable is alike, they are considered to be unlike terms. The last example I gave you is an example of constants. The constant number 5 and the constant term 7 are considered to be like because they're both constant terms. Then I gave you an example of unlike terms in the same row. 2 times b is not the same thing as the number 2. Okay? All right, so further down in this page, I said, what does it mean to combine like terms? What I want you to think about is an analogy to real life. If you combine two things, it usually means that you add them together. So in this lesson, I gave you the example, if I were to combine my money with your money, this would mean that we've added our money together. Okay, so we're only going to think of combining like terms to mean adding like terms. Okay, you can only add or combine terms if they are like. If they're not like terms, you cannot put them together. What you should notice by now is that the part of the term that does not have to be the same or identical is the coefficient. The coefficient does not need to be identical in order to combine like terms. Okay, so I'm going to give you a short example of what you're going to do in your assignment. In this lesson, I've put an example that I would like you to read through, and I'm also going to show you an example of how I want you to do it when you get on your own. I've jumped to the part where you're going to be doing the work on your own in Google Documents. On numbers 1 through 5, you need to probably review the material in 5C to be able to answer 1 through 5. Then for 6 through 10, you're going to be doing some combining like terms on your own. So I'm going to show you an example, and there's 4 things that I'm going to show you that you need to do in each of these problems. For part A, the first thing you need to do is to put each term into its own box, just like we did in 5A. For part B, you're going to rearrange the terms so that like terms are next to each other with constants listed last. Part C, you're going to combine your like terms, and we already said that that means to add. And D, you're going to write your final simplified expression with no boxes. So here is our example. We have 8 times x plus 2 plus 3 plus 5x. So the first thing you need to do is put those in the order they're listed into individual boxes. So I've got the 8x, the positive 2, the positive 3, and the positive 5 times x listed last. I'm not quite sure why this turned out red, so I'm going to change that. Okay, now the next step is that I need to rearrange the terms. So my variable terms are the positive 8 times x and the positive 5 times x. My constant terms are the positive 2 and the positive 3. They need to be listed last. So I'm going to leave the 8x in the front. I'm going to put the positive 5x next so that the like terms are next to one another. I'm going to list my constant term, positive 2 next, and my other constant term, positive 3 last. Now, the next step, part C, you must combine like terms. This means that you have to add this term to this term. And what you're going to find is that you're only going to be adding the coefficients, which are the numbers in front of the letter. So you're going to be adding 8 plus 5, and you're going to get 13x. Okay, so if you have 8 x's and you have 5 x's and you combine them, you now have 13 x's. Notice I don't change anything about the variable or the exponent. The only thing I do is work with the coefficient. The next thing I have to do is combine a positive 2 added to a positive 3, and that's going to give me a positive 5. And once I have put together or combined everything that I can combine, I'm finished combining like terms. So I'm going to take these out of the box. I have 13x and a positive 5, and we would read this as 13 times x plus 5. That's how you would read it when it's out of the boxes. So you actually have two terms in your final expression, and we consider this to be simplified because you cannot combine any more like terms.